Okay, let's move on to the next program where I am going to write statements for performing simple arithmetic operations. So I'm going to give the what what the program aim is inside comment program to perform arithmetic operations. Okay, so at first I will be dictating this using just the int data type. Okay, so let's move in. The first statement should be obviously hash include stdio.h, then hash include conio.h, then moving on to the void main. Okay, with the starting curly braces and an ending curly braces. Okay, now next I'm going to perform my statements. Okay, so it's just a program to perform arithmetic operations. I've not mentioned what comes next and what comes after, which all operations should be done and all. Let's do all the basic operations that we know. Okay, so I am going to input two variables, and yes, let's do addition, subtraction, multiplication, division. Division will have two steps to find the quotient, and yes, of course, the remainder. Okay, and we'll do something to find the power of a value. Okay, so this many steps we'll perform here in this program. So for that I need two variables at first. I'm not thinking about anything else. I just need two values to do all these operations, right? Basically two values. So I am going to give in a scanf where I am going to input a value for ampersand a. So okay, so before the scanf I need a printf statement. For what? For making the programmer understand that he has to input a value. So I'm just using the tab and the new line and enter the first number. Okay, so yes, so I'm just going to copy paste this, copy, because I have to do this for ampersand b too. So but go and change this as second. Okay, so enter the first number, enter the second number, so we have that completed. Now the first operation that we need to do is addition. So I am going to perform addition here, just indicating it with comments. Okay, addition performed. So in order to perform addition, we have two values here scanned into a and b. So we have a and b, so addition is just a plus b, right? But simply writing a plus b will not suffice our purpose. if we do a plus b, we get an answer, we get a result, right? And this result has to be stored somewhere. So for example, I am using a variable sum. So it has to be stored in the variable sum. But is this variable declared here? Whatever variable we are going to use in the program should be declared at the start of the function. That is a rule. Okay, so go back here and write sum. Okay, now it is always better that you give an initial value to all the variables that you use inside the program. Okay, that is because some compilers, assigns garbage values to the variables that you don't initialize. So that will make um, operations complex when you do complex programs. So it is always a better practice to give initial values to all the variables that you use. Now here in this line number 21, I when I wrote line number 21 for addition, adding a and b, I understood that I need a new variable sum. So if I have to use this variable sum, this same variable has to be declared at the first start of the main function. So I'm going back and I'm adding this particular declaration sum equal to 0 in the first local declaration statement. Okay, so yes, I have calculated the sum. Okay, so next I will be performing subtraction. Okay, so similar to addition, what we did, subtraction is a minus b, right? So in order to store the value, we need a new variable. So I am using sub as a new variable. So if I need to use sub here in line number 23, it has to be declared in the local declaration statement. So I'm going back and I am going to declare a variable sub equal to, I'm declare sub and initializing it with an initial value 0. Okay, now so subtraction is also over. Next in the line is multiplication. So I am coming back, I am going to perform multiplication. Okay, multiplication performed. Okay, for multiplying two numbers, we know the equation is a asterisk b, right? So to store the value of a asterisk b, we need another new variable. For example, PROD, product. Okay, so I'm using this variable product. But if I have to use this product variable in line number 25, I have to go back and declare it. Okay, rather than only declaration, I'm going to give it an initial value 0. Okay, now yes, the next in line is division. So as I mentioned earlier, division can be performed by in two steps, like first by calculating the quotient and the next by calculating the remainder. So in programming strategy, when if you have to calculate the quotient, let me write this here, division. Okay, so the quotient will be calculated by the step a by b. So a by b returns the quotient value. So for storing that result, I am going to use a variable qnt, which represents quotient. So in order to use that in line number 27, it should be declared above. So I am going to declare it as qnt and give it an initial value 0, right? Okay, so moving on to the next, it's like remainder, which is a part of division itself. So remainder can be calculated by using a mod operation, a mod b. Okay, so if I am going to do a mod b, that result has to be assigned to a variable. So for that I'm using a variable named rem, which indicates remainder. Okay, so in order to use this variable in line number 28, I need to declare this here again in the local declaration statement. So I'm going back and writing rem to declare, and I'm going to give it an initial value of 0. Right? I hope you understood. You're with me, right? Okay, the next operation that I am going to perform is the power operation to find the power exponential value. Okay, so for that you have to have this a new include header file included in your program, and that is math.h. Okay, so math.h contains an inbuilt function known as POW, power. Okay, which takes in two values. You can either calculate the power of A or calculate the power of B, or you can calculate the power of A raised to B times. Like power is what? 2 raised to 2 or 3 raised to 3. That's the power, right? So first I am going to write like this: A comma 2. That means we are going to find A raised to 2. Okay, you can also write B raised to 2. You can write A comma B and stuffs like that. Okay, use this power function. Okay, so I think, oh no, this has to be changed to power function. Okay, so addition, subtraction, product, division, and power function. Now, since we have everything, sorry, this power function, the result again has to be, assigned to a variable. So I am using a variable power. So if I have to use this variable power in line number 31, I have to go and declare it back here. So I am going to declare power equal to 0. Okay, and give it an initial value 0. Okay, so everything is done perfectly, I hope so. Now we'll print all the results: sum, subtraction result, product result, the division result, and the power result. Okay, so I am going to use a series of printf statements for that. Okay, the arithmetic operations results are, and I'm going to give a new line. Okay, so let me give a tab here and a new line here. Okay, there is if you're using Turbo C, I don't think that you will be needing this tab here, even if you are using Dev also. But now, because I'm recording my screen and I feel that my screen is like the output screen remains so adjacent to the left border, that is the reason why I am including this tab. Okay, you can choose whatever, in whichever style you need to print, you can do that. Okay, so the arithmetic operation results are, again a new line I'm giving, or else I'll just omit this new line here. Wait. Okay, again a printf here. I'll give a new line and a tab. Sum. Okay, so in order to print the sum, in order to print it on the display monitor, you have to use a format specifier again here. Since everything is int, I am going to use %d. Okay, and here you can just give a comma and write the variable name here, which holds the result. Okay, so when you're printing something after calculation, whatever you're wishing to print, that variable should be specified after comma, not in the double quotation marks. In the double quotation marks, you get to have the statement that you are going to print as well as the format specifier. Okay, So since I have this print statement, I'll just do the copy paste here. Sorry, copy paste printf, just convert it as subtraction %d, variable is sub. The variable that stores the results of subtraction is sub, so I'm writing sub here. Here you don't need this ampersand, only in scanf we use ampersand. Okay, now next printf, I'm going to paste the same thing, subtraction product result, again %d, which variable holds the results of product, prod. So I'm going to change this to prod. Again, this is division, right? So first we'll display the quotient, so qtint quotient, qnt, because that is the variable that holds the result of quotient. Now next I am going to display the remainder, so which is the variable that holds the result of remainder, rem. And next is the power function, power, so we will write power. Okay, I hope you're getting what I'm written. Get ch. Now for those who are doing this in Turbo C, please keep in mind to include a CLR SCR function here after the declaration statement. Okay, yes, so we'll go, I'm not sure whether this program is error free. We'll go check for some errors. Yes, compilation terminated, no such. Oh, okay, I have forgotten the dot. See how silly a mistake it was. We'll go save it again, we'll compile. Okay, for me, in this compiler, it doesn't support CLR SCR, so I just removed CLR SCR. So I'm going to compile. Yes, there are no errors. So I'm going to enter the first number. Let me enter 150. Okay. The second number I'm going to enter is 5. Yes, you get sum is 155. Subtraction is 145. Yes, it's right. And the product is 750. Yes, it's again right. The quotient, how did 30 come? 150 by 5, when you do the arithmetic operation, whatever comes in the quotient, it's 30, right? The value that came as 30 is assigned as quotient, and the remainder is 0 because it's completely divisible. And the power, yes, I had given a and 2, right? So the power is like 150 raised to 2, that is 150 into 150, that will come up to 22,500. Okay, now let's try this with another example. I'm going to compile the program. Yes. Okay, I'm going to run the same. But here I'm going to give a number that is lesser than the second number. Okay, so let me give 2 here, and let me give 10 as the second number. Excuse me. So here we get the result. The sum is 12, and subtraction we get it as -8, because 2 minus 10 will give us a negative number, and that is -8. Product again is 20. Quotient we get a 0. See here in the program, I'll show you. Wait, remainder we get 2, and power as 4, because we have actually calculated power as 2 raised to 2. See here, I had given quotient variable as float. That's the reason why we got a 0.5 0.0000000 as quotient. And yes, power, we have given a as the first argument for the power function. So a was given 2, and that's the reason we got 4, because 2 raised to 2 is equal to 4. So I hope that you are understanding how we get the output for the different arithmetic operations. You may be having confusions in how this quotient and remainder answers came up. So I am going to give a brief explanation on the quotient and the remainder. Let's see. Okay, here I am going to take a number 255. Now this is the same calculation that we do mathematically, okay, and I'm going to divide it with a number 2, okay. So our dividend is 255 and our divisor is 2. So how do we proceed? We take the first 2, okay, and we see whether it is divisible by our this particular 2. Yes, it is divisible, so 1 into 2 gives 2. Now here a subtraction is being done, so 2 minus 2 we get 0. So after this step, what we do is that we take 5 from here and we put a 5, this particular 5 along here. So here now again this process is repeated. We check for divisibility of 5 with 2. So we know that 2 into 2 is 4. So this 4 is being written here. Again a subtraction is being done. We get a result 1. Now we have one more 5 left in the number that we have taken, 255. So this 5 is being transferred down. So we get 15 here. So this 15 is divisible. Is it divisible by 2? Yeah. 7 into 2 we get 14. So after subtracting 15 minus 14 we get 1. So here you can see that our quotient is 127 and our remainder is 1. So this is how computer calculates. Now when we do mathematically, what we do is that upon getting this 1 here in the remainder, we put an extra 0, right, and we check for divisibility, and if it is divisible we put a point, a decimal point in the quotient part, and continue calculating the quotient until we get a remainder 0. That is what we do mathematically. But when we do programming, the compiler stops by saying whatever is coming as a remainder for the first time. So it doesn't calculate a remainder to, it calculate up to 0 until we reach 0. So what we have to understand here is that whatever comes on top is taken as the quotient, and whatever comes in the bottom will be taken as a remainder. No further traversing by additional zeros has been done in programming. Let's take another example. Yes, here I am taking my number as 2 and dividend as 2 and divisor as 10. So here you can see that 2 is lesser than 10. So obviously what will come in the top? 0. 0 into 10 gives us 0 and a remainder will be 2. So giving us a quotient as 0 and a remainder as 2. Okay. So this has to be kept in mind how computer calculates the quotient and the remainder. That's the reason why I have explained this here. Now let's move back to Dev C++. Okay, so I hope that you understood this